Okay, today's video is about other types of differential equations. But before we talk about other types, let's talk about our main type of differential equation. Our main type is always going to be that the rate of change of population with respect to time is directly proportional to the population. When we have that sort of problem, we can always know we're going right down to P equals CE to the KT. And then we can solve for the C and the K as time goes on. I know we have the steps, but right now we're going to focus on the types of problems that we have. The first other type of diffEQ is what's known as a difference problem. And you'll be told, for example, that let's take a roast. If you take a roast and you put it in the oven, the rate of change of temperature of the roast is directly proportional to the difference between the roast and the temperature of the oven. And they'll always give you the temperature of the oven, and they'll tell you like the temperature of the oven is equal to, let's go with 350 degrees. So whenever we see a difference problem, we know we're going to have a set of parentheses, and the difference is going to be the difference between the roast and the oven, 350 degrees. No matter what two items you have, you can always put your variable first and your constant second. And we could go through the steps to solve this, but it's exactly the same as the pocket problems. Whereas in the pocket we had P, the P ended up over here. On these type of problems, we're going to have that part end up over here. So the equation is going to end up being R minus 350 equals C E K T. If you wanted to get R by itself, you can move the 350 to the other side and get R equals C-E-K-T plus 350. And then we'll do it in class tomorrow if you didn't do it today. You'll see that you just find C and T the same way. You just got to be a little careful. You have to actually put the numbers in to test them to see what you get. So first kind is our standard differential equation. Our second type is our difference differential equation. Now there are some other types, but before we talk about those other types, let's just talk about the important words that come into play, and they are directly proportional and indirectly or inversely proportional. All of our differential equations are going to involve one of these two words, proportional. And they're always going to tell you that the rate of change of something, we'll start with P. It'll always start that way, and you'll come with that. And that's going to tell you it's either directly proportional or indirectly proportional. If it's directly proportional, K is there, and what is proportional to goes right next to the K. If it's inversely proportional, K goes on the top, and whatever is inversely proportional gets filled in right there. And they can put a whole bunch of different things in there, and they're going to use some important words like, you'll see things like square, cube, or square root. So to fill those on in, we'll see things like this. They'll tell me that the rate of change of population is directly proportional, let's say, to the square of population. So if it's directly proportional, I know I'm putting it next to it. If it's directly proportional to the square, it's going to look like that, KP squared. If they tell me it's inversely proportional to the square, that means the square of it is going to go on the bottom of the fraction. Well, what about if it's square root? If it's directly proportional to the square root, this becomes K, dP dt is equal to Kp to the 1/2. I'm always going to use exponents when I can. If it says it's inversely proportional, then the P to the 1/2 goes on the bottom. Of all the other ones, this is the other most common one we'll usually see. So let's try one. I'm going to let you know that the rate of change of population with respect to time is inversely proportional to the square root of population. That's our differential equation. We want to solve it, we want to separate, then integrate, and then solve. So whenever I can do these, if I can just cross multiply, I will do so. And I will get P to the 1/2 dP equals K dt. It's good form to write your dP's and your dT's at the end of the side of the equation, so the other stuff comes first. And now with this one, it's already separated out. It's done nice and easy. I'm now going to integrate both sides. And I'm going to get and integrate this. This is p to the 3 over 2. 2/3 p to the 3 over 2 equals kt plus c. So this is the general solution. And the generals are usually pretty easy to get. General solution. And then they may ask me for a specific solution. They may tell me, a lot of times these are more calculator related, they'll tell me that at time 0, when t equals 0, they'll say that the population is 500. So what do? I have to fill it on in there. I get 2/3 times 500 to the 3 over 2 equals k to the 0 plus c. So this part goes away. I get c. And I can solve for that other one. I'll have to use my calculator for that. I computed in my calculator that c was equal to 7453.56. Now that's what it's equal to exactly. I would round to the thousandths place, but I don't have a thousandths place. So now that I found c, I can use that to find the k by filling in my next point, which they gave me later on in the problem, which says when t was equal to 10, population was equal to 5,000. So, I know it looks terrible because I ran out of room there, but I filled in for C, which is here, I filled in for T, and I filled in for P. And now I'm going to solve it out. So I'm going to do 5,000 to the 3 over 2. Enter. Oh, I did 500. Hold on. So I put that in my calculator, and I got 235,702 equals 10k plus 7453.56. And I like giving us hard numbers like this, so I will subtract 7453.56 from both sides. Oop. Minus 7453.56. And I get 228,249 equals 10k. Then divide by 10. And I get that k is equal to 22824.9. Some really weird numbers I got for this one, but they are actually right. So if I was to rewrite this equation, oh, but they're going to let that keep going. There's the solution. Remember, this first one is the general solution, and this one is the specific solution. If you really want to get p by itself, you can. You also don't have to. You can leave the other terms there. They usually don't ask for it explicitly, but you can if you need to. Okay, I'll see you tomorrow.